would like to present the work we have done in partnership with the universities of Paris-Est, Paris-South, and a company called Leuville Objects. This work concerns the construction of a software architecture for big data. The outline of this presentation is as follows. First, I will describe the problem we are addressing, and then I will recall some reference works. Then I will present our use case, and I will describe also our software architecture, and finally our results, following by a conclusion. We have been working in big data for several years, and we are facing software management issues that limits our results. And so we use clusters of virtual machines where the software is installed and configured. But we are confronted with evolution needs that we cannot implement because their costs are too important. The consequences are sometimes difficult to consider. We use different Spark versions, and also we use different versions of HDP virtual machines. Works such as works of Dr. Bilal address the same difficulties. In particular, he seeks to remove pre-installed software that it does not need in order to free up memory, and thus improve the execution conditions of his programs. But this solution considered is construction of a VM based on background description. And the result is a construction. This kind of construction is not very scalable, and its technicality is very high. Also, similarly, Dr. Gio Costa and his colleagues have presented a specification of software architecture requirements for big data developments. And he takes the example of NoSQL storage system, the nature of which can vary depending on the project. Some will require Cassandra software, while others will use MongoDB or Redis for key values. It is not possible to install all the software, and because the evolutions forced to create more dynamic architecture, we are therefore moving towards a kind of software orchestration. Our use case concerns the analysis of logs, message from business application, but also from application servers, database server, and so on. Our goal is to move the files from these applications to our analysis workflow. Then perform a structured analysis approach, and finally build an AI model for anomaly prediction. First is data collection. it consists of some cron entries. Also, the data collection phase is built on the use of message brokers, such as Kafka server. Each message is read only once by the consumers. The volume of data is partitioned in order to parallelize the processing, and each partition supports the same kind of treatments. A similar work is done, and it includes a part of data cleaning and upgrading also. Then the scenario goes to the step of conversion into semi-structured data by exploiting the log format. These schemas helped to weight each part of a message. We proceed to the indexing of the data, and then the analysis is done by building an SVM model for a support vector machine. It allows to highlight correlations between data, and then the implementation provided by Spark gives metric to evaluate its use. This is our architecture, and each UML component corresponds to a Docker image. Our software architecture is built based on a Kubernetes orchestration. Also, we manage a set of Docker images, and we can describe, for instance, the many images, such as HDFS, official one, Hive, Spark, MongoDB, and so on. The main difficulty consists in the definition of services on deployments, to which we add the definition of virtual network and exchange interfaces too in gRPC protocol. The message broker collects data from several URLs and adds it to our data lake. All the services are managed by Zookeeper for fault tolerance. The data lake is built from several instances of HDFS containers. Each one exposes an interface for accessing files and another one for extracting data from log messages. Also, in the previous deployment diagram, these interfaces are modeled with the hook and the circle. For instance, here there are the two interfaces for the data lake. Then the data analysis is built with the Spark image. Its role is to extract information in order to validate the data and index it, of course. Finally, the output data are stored in a NoSQL database like MongoDB. As before, there are two interfaces. one for data management and another one for querying the data. As you can see on this diagram, this has the Data Lab API and the Data Lab HTTP. We have built a dedicated component for data querying. Initially, we had a Phoenix-based tool, but it was not enough, and we replaced it with a Hive Image because its SQL coverage was better, and in addition, its development API is easier to use, and it's possible to manage UDF, which means user-defined functions. Next, it's about the notebook. Every software change like that for big data needs a prototyping tool, more simply called a notebook in the big data world. Zeppelin allows the rapid writing Python code and Spark code. And this is why we have built a dedicated image for our project. In the second part of the slide, we can see a part of a Python prototype. And here we train our SVM model based on our log data, and the following parameters are used for this training. Next, it's about our results. Also, our results showed the feasibility of this architecture based on Kubernetes assembly. We were able to evaluate the cost of a software change by updating some components of our architecture. For instance, we have removed a Phoenix image, and we have replaced it by an Hive image. The results are convincing. We are convinced that we are on the right track. Finally, the construction of our AI model took place in good condition of training and use, and it's possible to consume log message volume which is enough for the moment, but in case of evolution, we are able to change our orchestration for that. Also, to sum up, we continue our approach, but this time with the aim of converging towards an evaluation of data consumption in relation to our software deployment. We want to develop new metrics collected this time by Kubernetes, and thus have a comparison between orchestrations. Also, from these results, we could be able to build data viz and to compare two scenarios, for instance. And thank you for your attention, and it will be a pleasure for me to answer to your question by email. And I just write I just want to display the first slide, and Cyril, Laurent, or me will be happy to answer to your question. Thanks a lot.